Hello, people. I've been needing a JAMMA power supply now for a few years, and this is where I'd put said JAMMA power supply if I had one. Now, I can hear some people already asking, what the heck is JAMMA? Well, JAMMA stands for Japan Amusement Machine and Marketing Association, and it's basically the standard wiring for a lot of arcade machines, and that's the wiring that contains like power, video, audio, and buttons and all that stuff. And so I have a couple of arcade machine boards here that I want to work on, but I need some way to power them. So today I thought I'd do a little project where I put together a power supply so that I can power up those boards. Now, it's not that JAMMA boards require like any special type of power supply or anything. And if you look online, you can actually find them. They're not hard to find or anything like that, and they're fairly inexpensive. Look right here on AliExpress, $5.32, but that's for like a wholesale price. You have to buy like 100 or more. However, I'm trying to not spend extra money and at the same time use stuff that I have on hand. So I dug out this old ATX power supply that I'm going to modify so that I can use it for said purposes. I've got an edge connector here that's going to connect to the boards that I need to work on. I've got a switch, and this is going to be used to turn this power supply on and off. And that's because this is an ATX power supply. So this green wire here, that needs to be grounded out to, ground, in order to be able to get the power supply to turn on. And the only other things I have here are some surface mount resistors, and that's only because I'm going to be modifying the switch here and making it lit so that I can have a couple of these LEDs in there. And that's going to be powered by 12 volts so that when the power supply is on, we'll have some indication that it's outputting power. I'm thinking that if I mount the switch like around here, that would be a good spot for it. So we're going to have to open up the power supply. And there's a lot of wires that we're not going to use from here. So a lot of this stuff is going to be eliminated. I really only need the 5 volt to 12 volt. And even though it's not really used on the boards that I have, the negative 5 volts is also going to go to the connector. Now, this power supply, when I got it, it was already used, and so it was like pretty dusty and stuff inside. So I actually had already cleaned it out on the inside, as well as checked for like any problems. And it had some adhesive on the board that I've all like cleaned up and everything, but that adhesive had also corroded like some of the components that were on there. And so all that stuff has been cleaned, and it was after I replaced the components that were damaged. I tested it, and it appears to be totally fine. So I think this is going to be a good candidate for this project. So we're actually going to have to start by opening it up so we have some access to the wires here. And I've only put like a few screws on it to hold it together, since I knew that it was going to have to come back apart. And here I only got 2 of the 4 screws holding the board into the rest of the case. And that will allow the board to come free. Now, working on power supplies like this is a bit dangerous due to the fact that there's high voltages on this side. So if you're thinking about doing something similar, just be careful, because it is pretty dangerous. The fan here was on a little header, so that can come off. So this will just come out if we just kind of pull it up like this. And so I really only want to keep like the black wires, since those are all ground, some of the red wires, some of the yellow wires, and I think it was the white that was negative 5 volts. Yeah, white is negative 5 volts here. This green one is the one that's going to be used for switching the power supply on and off. The gray one here is powered good, which is an output. Don't need that one. I can get rid of this one. This pink one here, that's a 5 volt sense wire, I believe here. Yeah, it's going together with this with this red wire here for sensing 5 volts. And that's probably going to be for voltage regulation. So I think what I'll do is I'll leave that one intact with that red one there, and that will go to the connector here. This purple one, that's the 5 volt standby. Don't need that one, so that one's gonna get removed, as well as these orange ones. Those are for 3.3. I don't need 3.3, so this brown one here is for the 3.3 volt sense. So I'm probably just gonna jump that to where the 3.3 volt output was. I don't know if there's anything special about that on here, but just to prevent any problems, we'll just jump that. This blue one is negative 12 volts. I don't need that, so that one's going to go away. And yeah, that's about it. Power good. I can pull that out. I'm just going to use my soldering iron here to find where it's at. And I can just pull it out like that. So that one's done. Okay, so here's the 4 that we don't need. For the rest that I do need to keep, I'm going to just trim them off as close to the connector here as possible, since I don't really need to keep this connector for anything. So I'm going to need 4 of the reds and 4 of the yellows, actually 2 of the yellows, and then at least 4 of the black ones. The green one is going to be connected internally, so I don't need to keep as much of it. So I'm going to cut that one just enough to allow me to connect it to the switch inside. I actually want to keep 5 of the yellows, actually, because one of them is going to go to the switch to light up the LEDs inside. Once I do that, I'm actually going to need a 5th black one too, so that I can hook that up to the switch for the ground to turn the power supply on. So let's see, what do I have so far here? This green one, I'll probably just trim like to about here, even though I'm probably, even that's like still like way too much. So that's that. The brown one here, I said I was going to jump to the 3.3 volt line, so I'm just going to trim that one like right here. Don't need a lot of that one. Now, the only unfortunate thing about the yellow 12 volt ones is that on the ATX, the 20 pin ATX connector, there was only one of them in use. And it would have been nice if I could have used like the ones from this 4-pin connector, but they are a much thinner gauge cable than the ones that are going to like the Molex plugs. Actually, the 12 volt ones don't even need to provide that much power, so I think these 2 thinner ones will be just fine because they're just as long as the other ones that I already have. So I'm just going to keep the 2 from here. All right, so that should be all of the wiring that I need. Everything else I can trim off. The only unfortunate thing down here is that a lot of these, they are like crimped together. As you can, I don't know if you're able to see it right there, but they have a little, it's like a ferrule that's soldered onto the board, and then that's where all the wires go. So I think what I'm going to have to do is just try to trim these as like close as possible to the bottom of the, or to the surface of the board. The ones that I don't need. Okay, so there we go. That's all the wiring that I'm keeping. I actually have a few extras here just in case. But once I'm done, what I don't use, I'm going to trim it off. I'm going to crimp on some like spade connectors there that I can just plug into this switch here. So in case I need to remove for some reason, I don't need to like do a bunch of desoldering or anything like that. I can just pull them off. One of these grounds is also going to go to the switch. And a positive is also, positive 12 is also going to go to the switch. So that's going to be these 3. Actually, what I'll do here is I'll just trim these short since they don't need to go very far. They're just going to be like right here. Okay, so the rest of this goes outside. These extra grounds right here I can trim off. And then the only other thing I need to do here is connect this 3.3 volt sense lead down to where the 3.3 volt originally came out. So I'm just going to strip this a little bit. Feed it back through the board, even though unfortunately the hole that came out of, it's that the 3.3 volt came from, is pretty big. It just needs to solder to the rest of the 3.3 volt supply right there. So I'm going to try to tin the wire at the same time, try to get it to stick down, which should be pretty easy here. There we go. I filled in that hole. So that's that. Could have made it shorter, but I left just a little bit there just in case I need to do anything with it. For our purposes here, I think the regulation of the 5 volt is the most important one. Okay, so I want to make sure I have enough room for that switch. Yeah, if I put it like around there. So I'm going to put a screw down in here to hold this board down so it doesn't shift around. Okay, there we go. So if it's like in that general area right there, it's a little too close to that. I would like it to be like right here, but if it's right there, this capacitor and this inductor are going to interfere with with that switch. I don't really like this area right there. I think I can make it work at about that height right there. But one thing I did notice is that capacitor, It's for some reason they left like really long leads on it, so it's not even touching the board. So I am going to make that like sit more flush on the board there. That'll give it a little more room for the connector to, comfortably be able to plug and unplug right there from the back. But as far as the space between this like grommet right here and the switch, it would leave like a tiny little bit of a gap there. So I think that should be fine. What I'll do is I'll take some measurements of the switch case. I'm going to mark it out here, and then I'm going to use this nibbling tool to like cut out the hole there where this switch is going to go. Although I am going to have to like drill out a hole first, so I'm going to remove the board here from the case so that I don't get like a bunch of metal shavings in it when I drill it out. We're ready now to make the cutout for the switch, and as you can see here, I've drawn out where I'm going to have to like cut the metal so that the switch can fit in there. And so one thing that I did here is, if you look at it from the side, I've bent this outwards just a little bit so that it allows me to get this piece of 2x3 so that I can put it behind like that, and that way I'm going to be able to like put some pressure down to drill into the case. And the way I bent this out here is, it was kind of like a last minute idea, but I basically took it up against the workbench, and then I just tried to like pull out on the bottom of the case there to try to keep this from getting as warped as possible. As you can see, it's still a little distorted, but it's not too bad. It should be fine once I bend it all back down. Thankfully, there wasn't like anything right here in the corners that would prevent it from being able to bend out that way. So I think it should be okay. And this having some room back here is also going to allow me to nibble it from behind, because otherwise I would have had to make a drawing like on the back of the metal right here so that I could see like where I was cutting, because as you can see, once you have this thing like in the front there, it's kind of hard to see where you're going. So this should make it easy to be able to get these lines cut out like as straight as possible. So I'm going to start by, first of all, supporting this from the back. And I'm going to use this punch here to make like a little dimple in the center. And I'm going to start off by drilling a small hole first. So that was pretty smooth. And now I need to enlarge the hole enough to be able to get the tool to stick through. And I think I'm going to use the little step tool here, so should go about to where I drew that mark right there on the bit. Okay, let's see if I can do this without having to support it from the back. I'm just going to set it down like that. Maybe that'll help support it a little bit. Okay. Yeah, that's good enough. So now let's see if I can do this. So that goes in like that. And as you can see, I can line up the edge of the cutting bit or tool right there, right where the edge of the marker is. So then I just pull on it. Makes a nice straight cut. And I can continue doing that all the way around. Okay, this little lip right here is preventing me from being able to get it all the way up to the edge of where I marked it right there. But what I can do afterwards is, now that I know, how much I need to cut, I could just go in from the top here and just put it in just enough to be able to cut into that line that I marked. So I'll just finish cutting it all the way around first. Okay, so I've got the rough shape there cut out. Now I can go in from behind and nibble out just a tiny bit more of where I need to. Actually, it helps if you start from see how this is like kind of like a tapered edge right there? If you start off with this like placed furthest from where you need to cut. So I'm going to start on this side like that and go this way, because it's easier for the kind of like the leading edge right here to bite down and keep it controlled than it is if you're like going in this direction. So I'm going to start off on this side. Make sure that that looks okay. Yep, right up to the line. And there it is. Got a little bit of material still left right there, but I'm not going to bother trying to nibble that out. I'm just going to use a file and try to get the edges here like nice and straight, and also deburr them a little bit, just because it is a little rough. But other than that, that cutout looks pretty good. I think the switch is going to fit just fine. Let's see, just a little quick little test fit. Yeah, it almost fits. It's just you need to smooth out the edges there a little bit, but that should work. Now, all that nibbling did distort the metal there just a little bit, so I'm just going to take this little block of wood here and just try to just kind of like tap it down, smooth it out just a little bit. And then I'm just going to use my superhuman strength here to bend this back. There we go. Got a little bit of bowing there, but I can straighten that out. Now, if it wasn't obvious from the previous shots, I desoldered the wires from the board here just to make it easier to maneuver and handle this thing. So I do need to resolder these back in again. And after that, I can pretty much permanently put this board back into the case. I did shorten the leads on this capacitor that was right there. And as you can see, so it's nice and flush with the board now. And I trimmed the extra leads. Now, I think the reason why they must have left those leads as long as they were, I did notice that they did it on a couple other caps back here. I think it was just maybe for like heat dissipation when soldering a lot of these big connectors here, where they crimped all of the wires that were, you know, like certain voltages together, because those would have required like a lot more heat to get the solder to like flow and properly bond everything together. But obviously, I don't need to worry about that because I'm not desoldering or soldering like anything big on there anymore. So it's fine for it to sit flush there on the board. So yeah, I'll just resolder these wires back in here. And we are going to crimp on the spade connectors, these little female disconnects. I ended up having to go buy some because I thought I had some on hand in my little box of like connectors. I did not. So I got a few of these here. Okay, at this point, I think it might be a good idea to give this thing a little test run. It should power on as long as I, connect these two together, which on the switch here would be these two silver connectors. So I can just plug this. I'm just going to kind of like put it in like that. I'm going to hook up a cable to the input there, and I'll see if it powers on when I go in that direction. Yeah, so that should be off. That will be on. So let's see what happens. Okay, so I've got the cable plugged into the back here. Let's see if the fan spins when I power on or turn on the switch. There it goes. So that's working. I was going to say, let's check the voltages while we have it open here. And I forgot that I didn't have the sense lead here hooked up to the 5 volts. So I've stripped a little bit of the insulation off of that and twisted these together. All right, yeah, so I'm going to set that off here to the side. Let's go ahead and turn this back on. Power supply is on. Let's see what sort of voltages we are getting here. Hopefully it's pretty close to what they're supposed to be. And as I was saying, I believe that for these older arcade boards, the 5 volt is the most important one. So that one needs to be fairly accurate. Let's actually measure it over here at where the sense is going to be. So let's see what we're getting there. 5.007. Wow. That's really good. I think I might have wanted it to be more about like 5.1, but we'll see what happens with 5 volts. So that's pretty good. Let's see what the 12 is. I believe that for the most part, the 12 is used for like audio purposes, maybe video. That's 11.57, so that's not great. It's not too bad either. The negative 5 volts. Let's see what that's giving us, even though, like I said, I don't think this one's going to be used at all. At least not for my purposes. -5. So yeah, everything seems pretty good. I'm kind of curious to see what the 3.3 measures. So I'm gonna poke around in here. 3.3. Oops, I lost the connection there. Oh, whoops! I punctured through the solder and I shorted it out. So I must have hit the overcurrent protection. Let's just let that reset for a second. Turn it back on. There we go. There he goes. 3.346. So like I said, yeah, not gonna use this voltage. So just jumped at it straight across. So I think that'll work. If I need to like tweak the voltages a little bit, I can do that later on. For now, I just want to get this all like built up and ready. Let's get working on modifying the switch now. First thing we're gonna have to do is pop off this rocker. We're gonna go off the rocker. So yeah, put that right there. I need something to help me hold this side in because this one here keeps wanting to pop back in. And I want to try to be careful not to let this thing go flying off because I already had to do it to me once. And I lost the spring for a day. Eventually I found it. But there it is. So the piece we only need to deal with is like this part right here. We see we've got that that moving piece of metal down there at the bottom. So let's just remove that. So we've got this little piece of like kind of like springy metal right there. That one goes to this gold colored terminal, and that's the one that's going to attach to 12 volts at all times. So that's going to go to my yellow wire on the power supply. I'm going to connect the ground to this terminal right here, and I'm going to make this one the green one to turn the power supply on. And the only reason I want to do that is to prevent anything from basically, or to prevent the power line here from having like any sort of continuity over to like this side here, which I don't think would cause a problem, but that's just so that it stays isolated at all times when the power supply is not on. And so what it does here is that center pin there connects to that terminal when the rocker is like pushed down in like on this side. So the LEDs on that are going to go inside of the rocker case, it's going to get its positive from this terminal and it's going to get its ground from that terminal because the spring itself is going to be used to transmit power to it. There's going to be a wire that we placed inside of there. Now, this originally did have an incandescent bulb. I don't remember if I mentioned it or not. I did remove it at some point, so as you can see, it's empty. But I'm going to cut this to keep 2 of these LEDs and make it fit like right around, like somewhere around there. I'm going to add a couple pieces of wire, bring those out from the bottom. And in the middle is where I'm going to grind away some of the copper so I can put this SMD resistor like right there in between the 2 LEDs to provide some current limiting. So we're going to have to do that under magnification because this stuff is getting kind of small here. And man, these things are dirty. Let's give them a little bit of a wipe down here. You can't really tell from looking at them from just the naked eye, but up close, they're pretty dusty. And I'm going to start off by just cutting like a little valley right here in the center of both of these LEDs. So there we go. That breaks continuity between the 2 parts. Just going to make a little mark with a blade. And I can grind off a bit of material from both of these sides. Trying not to damage the copper too much. It's not awesome, but that should be good enough. Okay, and let's add some flux. Solder in one side. Get it about right there. Get the side tack down. Okay, that side seems okay. Okay, I saw solder go down there, so I think that's good. Touch this side a little bit more. All right, shield your eyes, people. I'm going to test this out by applying positive and negative to the terminals here. 12 volts. Let's see what happens. There it goes. So, yep, that's working. Okay, so I want this to fit down there at the bottom. Something like along that length right there. So it looks like I'm going to have to trim it like right where like this negative, just beyond where that little negative sign is over here on the right side. And just beyond that positive sign right there on the left. And that should fit down there at the bottom just nicely. So let's see. Right about there. And right about there. Snip. If I need to shorten it a bit, I can just kind of like file it. But that's not too bad. Now, unfortunately, the hole on this side is like right below where the board is, as you can see right there. So I think maybe what I'll try to do is drill like a really, really tiny hole, like right here somewhere. And maybe I'll do the same on this side here. Actually, I think I have these switched around because this side here is going to have to be the negative. This side here is going to be the positive. So I got to flip these two LEDs around. But the hole's going to be pretty much in the same spot, so that way I can have the wires like pretty much just going down straight from this little tiny board. I'm going to put on this little block of wood here though, because I don't want to drill into the bench surface. Wow, that wants to move around a lot. Okay, so that hole is actually turning out a little bigger than I was hoping it would be. I'm just going to have to go in from the back side here. I think that'll be good right there. Well, I mean, that worked. It didn't work out as well as I had hoped. I think I should have just stuck with using like a really tiny drill bit on my like Dremel or something. But I mean, it'll work. So not too bad. Okay, so I've got the switch all done and reassembled, and I ended up having to reconfigure the pins coming out of the LED board because I forgot that the positive is actually not supposed to go down into that hole. It's supposed to come out and wrap around, and that's how it makes contact with the positive terminal up here. The negative did have to come down and then bend over into the inside for it to make contact with the spring that makes contact with this center terminal here. So we're ready to install this into the case now, and I should just be able to pop this in like that, and that feels nice and solid. So I'm pretty happy with how that turned out. The casing there ended up shaving some of the plastic off of the case there, but yeah, that's pretty good. So I just need to connect all the terminals here in the back now. So I said that 12 volt was the one at the very top. I was going to make the middle ground, and the power on lead is going to be down at the very bottom, just like that. So just to kind of keep things organized a bit in here, I am going to use some zip ties. There we go. That'll keep things nice and neat in here. So that should work for the switch. They kind of tuck in so I don't catch it when I put the casing on. So we can see the switch actually turned out better than I expected. I thought it was going to be like really close to that grommet there, but it's really not. So I think that's going to work out just fine. And nothing interferes with the switch. So what I'm going to do here is I'm just going to get bundles of these wires, and I'm going to put one piece of heat shrink on each one. And this is going to be so that once I solder it into the edge connector, I can insulate it. Now, I did mention that I was going to tie the 12 volt sent or the 5 volt sense to one of the 5 volt lines coming out. So for that, I'm going to use a little bit of a bigger, or a little piece of a bigger diameter heat shrink. And so these two are going to be connected together. And so that one's ready. I just need to put a regular piece of heat shrink on the rest. Now, I don't know if anybody's noticed here, but you can see that I'm missing one of the edge contacts there. And that's because I intentionally pulled it out. The thing is that on the JAMMA edge connectors, this section here is not used, and that's actually a cutout on the board. You can actually see it here on this filter board. So that right there will align with that sets of where there normally be pins. What I'm going to do is I'm actually going to put something in there. That way it kind of keys it so that this thing cannot be inserted the wrong way around, because we wouldn't want to have a bunch of voltages over here on these other inputs, even though like the grounds would still be connected to ground, but then like 5 volt, 12 volt, and all that would be applied to some of the controller inputs. So just to avoid that, I'm going to, like I said, make a little something there that will fit in there to key it. But I do want to pull this other one out. So I was just going to show how I was going to do that real quick here. And that's going to require, there's a little dimple right there on the end of the, or not on the end, but where the terminal touches the body. So if we push on that little dimple just enough, see if I can do it with this. Actually, I'm going to use something on the other side. I do not want to puncture my finger. Okay, I didn't do a very good job at it, but I think I did manage to push it in some. So now we should be able to push it out the front. See if I can use this to do it. Oh, I bent it. I may just end up having to break it off. Yeah, that's not going to survive. I'm just going to break it off. There it goes. Now I think I should be able to push the rest of it out. And there it is. So now that area is open. I can make something to put in there. And that's it for that. Now for the pinout, if we look at this diagram here, we see that starting from the top to bottom, we have grounds for the first 4 pins. So it'd be 1, 2, 3, 4. And then the next set is going to be like all 5 volts. And then we have -5, and then we've got 12. So on here, we're going to have ground, 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 5 volt, 5 volt, 5 volt, 5 volt. This is going to be -5 volt. But what I'm going to do here is, instead of using 2 separate wires, because I only have 1 white, I'm just going to loop it around both. And then I'm going to heat shrink over the top of both of them. And then the next set right here is the 12 volts. So those are going to get their own separate wire. So I'm just going to pop these in like this. There we go. So I'm just going to stick them in like that. Bring it over. I've got a loose strand right there. I'm going to have to try to get in there. But basically, I'm just going to bring these over like that. Solder it, and then put the heat shrink over it. So I'm going to do that for all of them. And then we'll be right back. Okay, I have to stop here. This not working out quite how I wanted it to. And you can kind of see here what's happening on this one here, although it's not as bad as some of the other ones were. But when I heat these up, because there's so much wire there that needs to heat up in order to melt the solder, in order to like flow over everything, the jacket starts melting, and the wires, like, they just start separating and getting like super bulky. So I'm going to switch my plans here a little bit, and instead what I'm going to do is I'm just going to trim off like a little bit from the end of these wires. And instead of looping them around inside of the eye of each terminal, I'm just going to solder it to the surface like this, which isn't quite as like physically secure in there, but as long as it's got enough solder to like stick there, it should be fine. I already did that with this one right here. Kind of, if I can pull this back, I don't think I can now. I think the heat like kind of made it shrink there, but yeah, as long as it's on there fairly securely with solder, it should be fine. For the -5, I ended up just squeezing the terminals together a bit like that. And so what I'm going to do is I'm going to tin those, and then I'm going to stick the 5 volt wire like in the middle, and then solder it secure. And that right there should be pretty good, because then once I put the heat shrink over it, it's going to look nice and even like that. So that should look pretty good when it's done. And just give it a shrink. There we go. Not too bad. That's actually kind of what I was hoping to go for in the beginning, but like I said, these were kind of being a pain there. So now I'm going to zip tie them a little bit. I did want to put some like loom over this, but I didn't have any on hand, and it's not that important, so it's all right. All right, I think that'll do. I'm going to add one more zip tie in here. Now I just need the top case. All right, and that's it. So, see if it turns on. I mean, it should. All right, let's see. Make sure the switch is off. Put it in. And yay, working. Let's double check that we're getting the voltages we're supposed to, at the pins we're supposed to. And this isn't necessary, but I'm just going to use it just to make it easier on me to just be able to like touch down in there. All right, so we got ground right here. And this should be 5. And we have 5. This should be -5. We've got -5. And this should be 12. And we have 11.57, which, like I said, I think should be fine. But if it turns out that these voltages are not adequate, then I'll probably end up tweaking the power supply. I just don't know for sure yet. And if you're wondering why I haven't populated anything else in here and why we're not doing anything else in this video about these, it's because I haven't figured out what exactly I'm going to do with that yet. I can't really test anything without having a power supply for it, so this was the more important thing to figure out first. I'm actually happy with how it turned out, and I like the way that switch turned out there too. So, yep, I think this is going to be good for what I need it for. And I mean, that's pretty much it for this one. I just wanted to get this thing built. So thank you all for watching. I will see you guys around the bench.